Okay, so now let's look at, now we're going to move into section 2.7, and so we're going to take this and apply it to marginal analysis, which we sort of already did a little bit of when we looked at the pounds of chocolate based on the price. So let's, I'm going to erase the algebra column, and I'm going to put up a list of business notation. Okay, so there's something called, so these are our business variables, we'll say. All right, we already have some of them, right? We already know the total cost, C of X. And we already know total revenue, we call R of X. And how do we find total revenue? Total revenue is the amount of money that you made, not your profit, but the amount of money you brought in. So if you're selling something, how do you know how much money you made? Yes, but before that. So if I sell 10 t-shirts at 20 bucks each, how much money did I bring in? 10 times 20, the number of items I sold times the price. So the thing to remember here is that revenue is the number of items, X, times the price, P. So that's a lowercase p. We have two p's, upper and lower. So let's just remember. So X is the number of items, and lowercase p is the price. But that makes sense. These are things that we know from real life.
Right.
What else do we know? We know that profit, total profit, capital P of X, and that's right, that's R of X minus C of X. So P, profit, is revenue minus cost. Okay, so here's a question. Here's a question that's a reasonable question to ask. If I increase my the number of items I make by 1, what is the exact cost of making the next item? That seems like maybe an easy question. Let's write that out. So we have, so what we're starting to talk about here is marginal analysis. And here again, we're going to have marginal versus exact. Marginal is the calculus projection, and exact is algebra, is exact. So if I wanted to look at the exact cost of making one more item, sometimes it's a linear cost function. We know what it is right off the bat. Sometimes we don't. So it's a reasonable question. So how would I find this if I don't have a nice linear cost function? Well, let's look at it this way. I know the total cost, right? Total cost, I'm going to have some formula for that. So if I made 0 all the way up to X items and X plus 1 items, total cost here, that's the total cost of all those items. Does that seem right? But if I only want the cost of this one, does anybody see what I can do to get to that? I don't want all of them, I just want the last one. Does anyone see anything I can subtract? Yes, kind of X. If I took, do I know the cost of those?
Yes, yeah.
That's total cost, right? So if I know the total cost of X plus 1 items, and I know the total cost of X items, if I subtract them, I'm just left with that one at the top. So that means that the exact cost of making that one more item is just going to be a difference. Cost of making all the items, cost of making all but the last item, that would be the cost of that last item. Is that okay? Or does anyone have a question they can ask? I know sometimes it's hard to formulate a question. Yeah?
I can't tell what you put in the very first exact cost of parentheses X plus 1. What is the...
It to be like the ST and at the top of the... Yeah.
First, X plus 1, for like the X plus 1, X plus first, which I don't know which it would be. So yeah, that's an ST, sorry. I don't know. I don't know how you call that, yeah. X plus first, that's a right, it's a question, X plus 1? It's okay to laugh early in the morning, I promise. Okay, so what do we call this then? We could really call this delta C, right? It's a change in cost. We just looked at how to approximate change in cost with calculus, right? So if I'm looking for a delta C, what's my delta X? How much did X change by if I went from X to X plus 1? 1, right? I just went up by 1. I just went 1 more. So I here know that my delta X is 1, and I'm trying to find a delta C. So that suggests to me that I may have enough to actually use calculus to project. And so these are, when we talk about projections for cost or revenue or profit, we're saying if we stay on the trajectory that we're on, this is what we can expect. So what we're going to use for calculus then is the differential dc. That's going to be the derivative times dx. I know this. Ooh, that's 1. It's always going to be 1 if I'm trying to find the x plus first item. It's always going to be 1. So in fact, then I can simplify this to the change in cost, the projected marginal approximate, that's another word. Change in cost is just going to be the derivative. So all I have to do is find the derivative, plug in x, done. So in point of fact, this one's easier than doing it the exact way. We can do this with cost, revenue, profit, we can do it with all. So it's all the same thing. So this then is called marginal cost. So let's see, that's right over here. So we have total, and we already had average with the bar across the top. So I'm just going to write it for cost, but it's the same for all of them. So average cost has the bar, marginal cost is the derivative. I hope this will show. So we have total cost, regular letter, average cost, letter with the bar over the top, and marginal cost with the derivative apostrophe. Okay, so let's give this a go. Let's try a problem. So I'm going to do page 170, number 34. Read something like this. The total cost in dollars of producing X number of guitars is given by, so total cost of X guitars is C of X equals 1,000 plus 100X minus 0.25 X squared. So if you think about the previous cost equations we've looked at have been just this part. We're saying, oh, you have some original fixed cost and it's $100 per guitar. But we also know that sometimes when you make more and more of something, you can save money in other places, right? Maybe if you make enough guitars, then you can buy in bulk and you can save some on your supply cost. So it's not unreasonable to have something that's more complicated than just linear. That's not unreasonable. So then the question is, find the exact and approximate cost of the 51st guitar. Okay, exact delta. I'm making the 51st one, the total cost for that, minus the total cost for the first 50, that's the exact cost. Approximate, calculus. Or better yet, we can just go straight and write C prime of X, because that is the marginal cost, is C prime. We don't even need to write that little DC, we just know that we're doing that. Okay, so delta C is going to be the cost of the 51st one minus the cost of the 50th one. Because these are total costs, right? So this is the total cost of making all 51 minus the total cost of making all 50. That's going to leave me with just the 51st one. I didn't do that one. I tried to work ahead. What's that?
I was mumbling myself,
Okay.
apparently not that quiet.
No, I have good ears. I'm a mom.
I was just saying, like, when it says find the exact first, I was like, I was just wondering why you went straight to the calculus instead of just doing the exact.
Because it's going to turn out the calculus is actually faster. Here, faster, and when it comes,
I was,
yeah. So no. Yes. Well, in this case, we're doing both. Yes, but in real life, a lot of times you're going to look at projections. Assuming we were going on the path that we're on now, what would be the projected cost? So you hear the word projected a lot. That's what this approximate is. So let's just do both ways so we can compare the numbers. So this half the class do C of 51, and this half do C of 50. And tell me what you get. I did one of them to check my work. Does that look right? And C of 50, did anybody get that one yet?
53.75.
Say again?
53.75.
53.75. So altogether, 74.75? Which makes sense because we expect 100 more per item and then subtract a little bit more. So that seems to be about right. So 74.75 is the exact cost to make the 51st guitar. Okay, let's look at the projected cost. Projected cost just says find the derivative and plug in what? Not 51st, but what your starting point. I'm starting at 50. I'm going to project what happens for 51. So you have to plug in 50, your starting point. So here, what's the derivative? Should be easy. 100. 0.5x. So if I want to know the approximate cost of the 51st guitar, I'm going to put in 50. 100 minus 25 is 25. So approximately $75. And so they agree. So just remember, exact is algebra. That's actually plugging in the 2 points and computing the exact value. Calculus is the projected value, the marginal. Marginal because it's saying one more. I just go one more. What's my little extra marginal cost? Or the approximate cost, or the projected cost. Those are all phrases that you'll hear. So if I just say find the approximate cost, I just go straight to the derivative and I plug in, importantly, not 51, but the number, remember that's what I'm projecting for. So I'm starting at 50 and projecting for 51, so I start with 50. Okay, is that okay so far? All right, so let's look at another one. All right, this one is page 171, number 44. Okay. The price P in dollars and the demand X for a steam iron, ooh, very exciting, steam irons, is related by this. We know that price and number of items are related. The higher the price, the lower the demand. And so we know that in this case, here's our equation. So we have to do a couple of things. We're going to find the price in terms of X. Right now we've got X in terms of P. We need to solve it the other way. Find the revenue. And then find the marginal revenue for 400 steam irons and interpret. So find and interpret. So we need to remember that those mean different things. Find is a number, interpret is the word understanding of that. And along the way in here, we're going to talk about domain. Okay. So let's come over here and talk about price and demand first. Is there any number that the demand cannot be? Can demand be 1,000? What's that?
Should be negative.
Does it make infinity?
It could, well, yeah, normally we don't go out to infinity, that's true, but definitely we know we can't make negative number of irons, right? So we know for certain that x has to be greater than 0. We know that. What about price? Any limitations on price?
It can't be free.
It can't be free, it can't be negative. So we know that P also needs to be greater than 0. I guess you could give it away free, but I don't think you're going to be able to charge somebody, here, come buy my iron and pay me money
Well,
too.
if the item messes up,
I'll pay you. That's,
it's like
well,
main thing.
yes, you're right, we'll get back to that. That's a whole other separate, that's probably an econ class issue. So, okay, so we know these two things. This is going to be important because we need, these are going to have domains. We don't think about every valuable, can't talk, every value of the variable x. There are going to be some limits. So let's do this first thing. Solve for p in terms of x. So so I just need to solve this equation for p. That's what it means. I've got x in terms of p. Now I just need to write it the other way. So 20p plus x equals 1,000, just because I like positive numbers. 20p, 1,000 minus x, p, 50 minus 1/20th x. I did that fast because I don't want to spend a lot of time dealing with algebra. So I know that this one, p is equal to 50 minus 1/20th x. So now I need to think about what is the domain. Okay, that's not good for all values. First off, I know that x has to be greater than 0, so I know that part. So then the question is, how high can x go? How high can the demand go? Well, at some point, the demand will get so high that I'll make the price negative. Does everyone agree that's true? If I kept putting bigger numbers in here, bigger and bigger and bigger and bigger, put in 2,000, I get 50 minus 100, negative price. That doesn't work. So clearly there's an endpoint to where that makes sense. That endpoint, one way to look at it is if I put in p equals 0 up here, right? As my demand goes up, the price is going to go down. As soon as my price gets down to 0, that's the demand. So the easiest way to find that limit is to put p equals 0 up here. Because once p equals 0, that's as low as it can go, right? Which means x is 1,000. So this is only good for 0 to 1,000 items. Beyond 1,000 items, I have negative price. It doesn't make sense. So this is part of your homework, and people get tripped up on this. So to find the domain, you always know x is greater than 0. You always know that unless they tell you something more than that. Sometimes they'll say greater than 10 or greater than 1. The endpoint comes from looking at what happens when price equals 0, because that's as high as the demand is going to go to drive the price down to 0. Is that okay? We'll do some more. Let's look at this one. Find R of x. How do I find R of x? I know the price, I know the number of items, so what do I do? Yeah, revenue is the number of items times the price that you charge for them. So the number of items, x, times the price. And then, yeah, go ahead and multiply it out. Should you use 1/20th or 0.05, I don't care. So whichever one makes you happier. What about the domain for this one? Exactly the same. The domain is exactly the same. So once you find that domain the first time, you're done.
Is that always going to be 0 and you just plug in 0 to your original?
Yeah,
negative
x
0?
is always going to be greater than or equal to 0 unless the problem states something different than that. Because maybe the first 10 items do something, they have a very, maybe when x is below 10, there's a very strange price structure. So they may give you a different number here, but as soon as price gets to 0, you know you've maxed out on the number of items. So I find that to be the easiest way to find the domain, is to put price equals 0, and that gives you, because they go backwards. I mean, they're opposite of each other, right? As one goes up, the other goes down. Yep.
But in terms of like real world application, that is a theoretical domain, right?
Well, yes and no, except that when I get up to this number, I mean, assuming that this is a valid model.
Because the domain could be lower, like we know the domain can't be higher,
Correct.
but at the same time, the domain could be
Yes.
8,000.
You might-
Factors we don't know.
You're right, you may be limited by what you can produce.
Or any number.
Yeah, any number of things, right, exactly. So yeah, in this class, we're not, I'm giving you the tools so that when you take your econ class, you can understand all of that.
Right.
Yeah, so that's a good point. Okay, so marginal revenue. Marginal revenue, remember, is the approximate revenue, but that's very easy. Marginal revenue, R prime. That's just what it is. Because remember, our delta x is 1, so when we look at our differential, it's just R prime. That's even the name we call marginal. So if you just remember the name of it, it will tell you what to do. So is this easy derivative to find? Sure. 50 minus 0.1x. So what's the marginal revenue that we're projecting based on 400 irons? So just put in 400. 50 minus 10. So 10 watts. This is a derivative. So it's not just dollars.
For iron?
Yeah, for the next iron. $10. I'm going to just say per next iron. And if you're not sure of units, you can always do this. R prime is dRdx. Revenue dollars per item. So when you write the derivative this way, and when we get to related rates, that's going to help us too. When you write the derivative this way, it tells you the units. You can see them. So we have found the marginal revenue. What does it mean? What does it mean for the marginal revenue to be $10 for the next iron?
So it's 10 additional dollars per iron you create.
Right, so if I'm going to make more irons, I
With
can
the
expect
base.
my revenue to go up $10. Yeah, per iron. How far can you take this? Well, you could take it, another couple irons, but would this necessarily hold for the next 100 irons? No, because
It's not exact.
it's approximate, and so you can only take that approximation so far before the curve changes too much and you need to pick a different starting point.
Right, but your price is only 1,000 minus 20p, like it's not like 1,000 minus 20p times 25p squared. You know what I mean?
Right,
It's not a
yes.
quadratic, so it's
Right.
going to be linear anyways.
Right, exactly, but
So
I guess
it
just,
probably would fit.
right, but in general, yes. So for this particular case, yes, because this is a line, so it goes forever at the same slope. But in general, if this were more complicated, which is not uncommon, you can have log relationships, right? We've done regressions now, so you can have exponential, probably not here, but you could have log shapes. And so this will not always be so simple. Generally, in this class, it will, mostly, definitely on tests, but it doesn't always have to be. So generally speaking, this only works for a few more items. After that, you need to change your set point to another starting point, not 400, but maybe 450, and then see what to project beyond that. Okay, so let's look at one last concept, and that's break-even point. You guys already know what that is. When do you break even? What would that mean to you? You're in a company, you're
You
selling
make as much
t-shirts.
as it took to product the.
Yeah, when the cost equals the revenue, you broke even. So you guys already know what that is. So, sorry, I'm writing kind of low, break even. The break-even point is where revenue equals cost, or profit is 0, right? Because that's the same thing. If revenue equals cost, profit is 0. So you can think of it either way, whichever way makes more sense to you. So revenue equals cost, or profit equals 0. Okay, so let me draw a picture which will help, again, explain some of the domain issues as well. All right, so now I'm looking at page 172. Number 46, A, C, and F. I'm just going to do a few of them because I'm hoping to have a little bit of time for you to start on a problem and homework. Okay, so we talked about the break-even point. In our class, a common, this is not always, but a common set of curves is going to look like this. Notice I'm not giving a lot of attention to negative things, right? Because we're dealing with price and items, so we don't really have negatives. Typically, your cost function might be linear, it might be not, but generally it increases, right? The more items you make, the more money it costs. That makes sense. We also know, so this is our cost function. Here's our revenue. We know if we make 0 items, we make $0. That makes sense? Mm-hmm. Right? I mean, if I don't sell anything, I don't make anything. And all the way, if I start to make too many, eventually I drive my revenue down to 0 because I can't, the price goes down to 0. So it's going to end up, this is my domain. Okay? It always starts at 0, almost always. And at some point, the demand is, and the price relationship drive the price back down to 0, so the revenue is 0. So here and here are my break-even points. What would I call in here? When my revenue is greater than my cost, I would say that I have made a profit. So actually, the domain for profit, the profit really only occurs in a much narrower range. Because out here, when my costs are greater, what do I call it out there? I take a loss. So I can either make a profit or take a loss. Maybe should I have put this up in the beginning? Maybe this would have been helpful to kind of set up everything. I think this kind of draws everything together. So we have generally increasing cost. We have generally some sort of revenue equation that says at some point I'm making revenue, but then at some point I set the price too high and I start losing revenue until I get down to 0. There are break-even points that you can find. Here it's profit, here it's loss. So when I ask for the domain for profit, it's between the break-even points. It doesn't go as far as the whole revenue. I'm making revenue for a longer time than I'm actually making profit. So this is between the break-even points. Okay, so let's look at this problem. Okay, so this one says the price-demand equation and cost function for HD TVs. Much more interesting than irons. We have this. We have X equals. So this is the demand based on the price. It means every time I bump the price up $1, I lose a sale. I lose 30 sales. Is what that's saying. Every time the price goes up, the number of sales go down. Okay, and then I also know the total cost, 150,000 plus 30x. So a basic cost structure. I have some initial outlay, and then it costs me $30 per TV to make. Somebody's making a lot of money, right? $30 to make an HD TV and then sell it for how much?
So a lot of HD.
Yeah, that seems maybe not quite right, but okay. So now let's look at A. A says to find the price, we need to find this price. So A is solve for price. And then find the domain. So solve for price just says take this one and solve for P. Because this makes sense to write it this way, don't you think? And this to me makes more sense to write in terms of understanding it. For every $1 I increase, I lose 30 sales. But I can't write my revenue that way. So for revenue, I have to solve for P. So when I solve for P, I think that's right. Again, I'm trying not to spend time on algebra. Yes. So what is the domain for that?